So today it is called Area of Regular Polygons, Day 2. And we're going to start with number 6. And there's a picture on number 6. You don't have to draw the picture. There is a circle. And then there's an octagon drawn inside the circle. Since all these vertex points are on the edge of the circle, then this is called an inscribed octagon. And the directions say that the octagon is regular. What does that mean if the octagon is regular? Yes?
All the angles and all the
Yeah. All the angles are the same, and all the sides are the same. Now, it doesn't really look like, I didn't do a perfect job of drawing the octagon. Looks like this top side's maybe a little longer than especially that one. But we're going by the facts, not by the appearance. It's a regular octagon. All the sides are the same length, and all the angles are the same length. And they tell us that the radius of the circle is 3 inches. And then they ask us to find the area of the octagon. So the circle is kind of there just as extra. We don't need the area of the circle. We just need the area of the octagon. So what's the formula for the area of an octagon? Yeah. 1/2 times perimeter times apothem. Now, that formula only works for regular octagons. It works for hexagons and pentagons, any regular figure. So this is where we're going. This is what the question's asking. We're going to use this formula, 1/2 times perimeter times apothem, to answer the question. Because the question says, find the area of the octagon. But it's going to take us a while to get there. So this radius is 3. So I'm going to go ahead and draw in the radius. Here's the center of the circle and the center of the octagon. And then the radius would go to the edge of the circle. So that's 3 inches. What we need is this angle. We need to know how big these angles are before we can figure out the area. So there's a different formula that tells you what all the angles add up to. Yeah, Maddie's. It seemed like you, well, I thought you mouthed 180.
Oh, no.
Okay, sorry, my fault. So we're trying to figure out what all these angles are. So there's a formula that tells you what the angles add up to inside a polygon. It's been about a week since we had it, but does anybody remember that formula? Yeah.
Is that like 180 times points minus 2?
Good. So here's the formula from about a week ago. And the purpose of this formula is to tell you what all the inside angles add up to. Now in this case, this is an octagon, so the n is 8. Because the n stands for the number of sides. That's why I was hoping that you were thinking of 180, but it's all good. It's all good. In a triangle, it actually adds up to 180, right? The 3 angles. But in an octagon, It adds up to 1,080. So what this means is this angle plus that one plus that one plus that one, all of them add up to 1,080. So how can I figure out just one of them then? Yep. Divide by 8, right? Because it's regular, so all the angles are the same. So if you just take what they all add up to and divvy it up evenly, I can't remember, maybe 135? Just did it about half an hour ago. Okay, yeah, 135. So that means that this angle here is 135. And this one is 135. And that one's 135. They're all 135 because it's a regular octagon. Now in a different octagon, this could maybe 140 and this one 130. But since it's regular, they're all the same. So that means this angle up here was 135 before this radius came along and sliced it. So this was 135, and the radius cuts it in half. It bisects it. So now we're going to do 135 divided by 2. And finally, now we know what, not finally, but we know this angle now is 67.5. So I used this formula to figure out what all the angles added up to, divided by 8 to get each angle, and then divided by 2 because the radius sliced the 135 up there in half. Okay, but the real goal of this problem is to find the area of the octagon. This is where we're going. So what does the A stand for in this formula? The apothem, right? So we got to go back to our picture and draw in the apothem. The apothem starts at the center of the circle, well, at the center of the octagon. And where does it go? Is this the apothem? How do you draw an apothem? Yeah. It has to be perpendicular to the side. So it could go here or here. But since we've already got this 67.5 up here, I'm going to go like this. So now that's the apothem. And I need to figure out that apothem so that I can plug it in here to figure out the area. All right, so now we're going to look at this triangle. And this triangle is a right triangle, and that's good news because we know a lot of stuff about right triangles. We know that Pythagorean theorem applies to it, and then we also know sine, cosine, tangent applies to it. We have this angle. The 3 is across from the 90, so that's the hypotenuse. 3 across from 90, hypotenuse. What's this? It's the opposite, right? Because it's across from the 67.5. So we've got a right triangle here, and we're dealing with opposite and hypotenuse. So we can use sine. The angle is 67.5, so we're taking the sine of 67.5. And that should equal the opposite over the hypotenuse. So looking at the triangle, the opposite is A, the hypotenuse is 3. So that should equal A over 3. So we're doing this to figure out the apothem, so that we can take that number and put it over here to find the area. So now I'm just going to type in sine 67.5 in my calculator. get that number. So I'm getting 0.924. That's tenths, hundredths, thousandths. So this is 924 out of 1,000. And then you cross multiply. Three times 924 is 2,772. 1,000 times A is 1,000 A. Then divide by 1,000. A is 2.772. So we're getting close now to being able to find the area, because now we have the apothem. We come over here to our area formula and plug in 2.772 for apothem. We just have a little bit more work to do to figure out the perimeter, right? So back to our picture. If we're going to figure out the perimeter, we need to know what this length is. Or alternatively, we need to know what this length is. So first I'm going to find out this length. I'm going to call that x. Now how can I find x? You could use Pythagorean theorem, because 2.772 squared plus x squared equals 3 squared. That's good. Or you could do cosine, because x is adjacent. So 2.772 squared plus x squared equals 3 squared. So I'm getting 1.147. So then back over to here, that means this is 1.147. So then how big is the side of the octagon? If this is 1.147, how big is this? 1.147, right? There's two of them. So you just take 1.147 times 2 to figure out the side. So put 2.294. That's one side of the octagon, right? So then how do I figure out the perimeter? Thank you, Charlie.
Add them all together.
Yeah, how many of them?
8 together.
8 of them. So this plus this plus this plus this 8 times. You could just multiply it by 8. So 18.352. I took this number times 8 to get the perimeter. And that's 18.352. Then that comes over here. And finally, we have all the information we need to figure out the area. Just take 1/2 times that perimeter that we figured out times that apothem to find the area of the octagon. That would be square inches, right? Because it's area. Okay, so there was a lot going on in that problem. This formula, which tells you what the inside angles add up to. This formula, which applies to right triangles. Pythagorean theorem that applies to right triangles. And then the area of regular polygon formula. Are you sure? Are you sure you're okay? You seemed like you were pretty much following. Thank you so much for listening. Do you need to backtrack and ask any questions about any of that? Okay, the good news is there's only one of the